When it comes to innovation, there's this massive gap that can make or break pretty much any project. It's the gap between a brilliant strategy on paper and the seriously complex tech you need to actually make it real. In this explainer, we're going to explore the hidden bridge that connects these two worlds. So let's kick things off with a really big question, maybe the biggest one of all. How do you build something that has never, ever been built before? Whether it's a brand new act, a cutting-edge defense system, or some revolutionary product, this is the core challenge that every single innovator is up against. And the reason this is so tough, well, it brings us to our first big idea. We are living in an age of incredible complexity. The systems we're trying to create today have so many moving parts, so many variables, that the old ways of doing things just don't work anymore. And we're not talking about small changes here. The scale of this disruption is just massive. As the World Economic Forum points out, this isn't about little tweaks here and there. The fourth industrial revolution is rewriting the rules for every single industry. And that means our old project management playbooks, they just can't keep up. So to handle this new reality, two major disciplines have really come to the forefront. The easiest way to think about them is as two different teams, the planners and the builders. They're both tackling the same complexity, but they're coming at it from completely different angles. On one side, you've got the planners. These are your strategists. They're looking at the big picture, the market, the business goals. They're constantly asking, why are we doing this? Their favorite tool is something called technology road mapping. Then you've got the builders. These are your engineers, the people in the trenches, figuring out the nuts and bolts. They're asking, what are we building and how do we make it work? Their world is called systems engineering. Okay, so let's dive into the planner's world for a second. Their go-to tool is technology road mapping, or TRM for short. Just think of it like a strategic map for the future. It gets everyone on the same page about the know why, that's the purpose, the know what, the stuff you'll actually deliver, and the know how, which is all about the resources you'll need. And here's a perfect example of what one of these roadmaps looks like. See those different layers? You've got market needs, products, and technology, all laid out over time. It's this incredibly powerful visual that draws a straight line from a high-level strategic goal right down to a specific piece of technology. Now, let's switch gears to the builders. Their discipline is systems engineering, or SE. It's a super structured way of turning complex ideas into a working reality. And the most critical part of SE, the absolute golden rule, is its needs-first approach. Before a single line of code is written or a single piece of hardware is designed, SE is all about rigorously defining what the customer actually needs the system to do. And the process itself is incredibly logical. It all starts with understanding what everyone involved, the stakeholders, actually needs. Then you translate those needs into rock-solid requirements, develop a few design concepts, and then you test and analyze those designs like crazy. So the output isn't just a product thrown over the wall. It's a validated solution that you know for a fact does what it's supposed to do. So we have the planners with their big picture roadmaps, and we have the builders with their detailed, structured processes. And for the longest time, these two groups have basically been in their own little worlds, working in silos. But the real magic, the real breakthrough, happens when you finally bring them together. It seems like a simple question, right? But the answer is honestly transformative. What happens when your grand strategy actually informs the day-to-day engineering, and when the realities of that engineering work feed back into the strategy? You get this, a truly symbiotic relationship. Just look at the feedback loop in this diagram. The roadmap at the bottom is feeding information into the systems engineering process at the top. But then, in return, all that engineering work provides real-world data that refines the roadmap, making it smarter and more realistic. It's this powerful cycle of constant improvement. And the benefits here? They are huge. The roadmap makes sure the engineers are actually working on things that matter to the business. And in return, the engineering process acts as a reality check, making sure the roadmap isn't just some fantasy. But maybe the most important thing is that it creates a common language that everyone, from the CEO down to the junior developer, can understand and use. Okay, this all sounds great in theory, but let's see how it actually works in the real world. We're going to walk through a quick case study that uses this exact approach to simulate a really complex radar system before a single piece of it is ever built. The secret sauce that makes this all possible is a technique called model-based systems engineering, or MBSE.
So instead of relying on thousands of pages of static documents that are outdated the second you print them, MBSE uses a dynamic, digital model of the entire system. This model becomes the one single source of truth that everybody works from.
All right, so for our example, we're looking at a simplified radar warning receiver, or RWR, which was modeled by engineers over at Saab. As you can see, it's broken down into three main chunks. You've got the receiver that detects incoming signals, the signal processor that figures out what they are, and a system control manager that acts like the brain of the operation. And the goal here is pretty straightforward. We want to use that digital model to run a virtual simulation. We want to test the system's logic, see how it behaves, and find any communication bugs before we start building any expensive hardware. This is all about catching mistakes early when they're cheap and easy to fix. Okay, let's watch the simulation in action. First, we trigger a start event. Now, keep an eye on the screen. You can see the system manager's state, its current mode, instantly flip from idle to startup. The test is officially running. Now, here's the cool part. Because this is a connected digital model, that start signal doesn't just sit there. The logic that we built into the model, you can see it here in this activity diagram, automatically passes that signal along to the other two main parts of the system. And bingo, there's the result. The signal gets to the receiver manager, and you can see its state change to started. Success. In just a few seconds, we've basically proven that a key piece of the system's logic works exactly the way we designed it to. So let's pull all of this together. We've seen the planners and their roadmaps, the builders and their processes, and now this incredible digital bridge that connects them. And this brings us right back to the central idea of this whole explainer. It really all boils down to this one simple, powerful truth. A planner's greatest strategy is just a daydream if you don't have the builders to make it real. And the builders working away without the direction from the planners, well, that's just a recipe for chaos. It's a nightmare. You absolutely need both working hand in hand. So what's the bottom line here? In the complex world we live in today, connecting your strategy to your execution isn't just a nice to have. It's a competitive necessity. It's how you win. Model-based systems engineering is that digital bridge that finally connects the high-level plan to the deep technical details. And simulation is the tool that lets you de-risk your biggest, boldest ideas before you spend a single dime. So I'll leave you with this one final thought to take away with you. Think about your own organization, your own projects. How clear is that line of sight from your highest level goals all the way down to the daily work of the people making it happen? How connected, really, is your strategy to your execution?